So a particle of mass m charge q is attached to a light string thread of length L. So what is given? According to this question, there is a charge plus q. It is connected with a string, and right now it is in vertical condition. Why it is in vertical condition? Because it is being repelled by a charge which is fixed in a surface. So there is a charge of plus q, right? It is fixed and it is under repulsion. So right now it is stationary. But the question is saying that if you disturb it little bit, right? And they are asking that what will be the minimum value of q so that this present condition is stable equilibrium. Stable equilibrium means if you disturb little bit, it will again come back to that. So let us disturb it little bit. I will roughly show this diagram like this q here, and note here that this length is nothing but the L, right? This L and this L, both lengths are equal, right? Of course, this is a string here, so this length is L. This length, how much it will be? Because these angles are very small. Note that this circular arc at the center, certain angle theta, and this is like a circumference of this, because this is like a diameter. So this angle is theta by 2, right? So if you try to draw the forces here, so this electrostatic force will be along this line, right? Electrostatic force is going to be along this line. This is electrostatic force, and tension is along this line. So tension, this angle is theta, so this angle with the vertical is also here, mg is acting like this way, right? So this angle is theta, but this angle is theta by 2, right? So this angle is also going to be theta by 2. So here also this angle is theta by 2. Now try to resolve all the forces perpendicular to tension. So perpendicular to tension are the restoring forces. So this will be Fe sine theta by 2, and this side is mg sine theta. You know that. So net force must be this direction. That means this Fe sine theta by 2 must be greater than mg sine theta. So from here take theta as very small. So this must be greater than 2 times of mg, right? And this force is equal to k q1 into q2 by r square. So total distance, because the angles are negligibly small, you can take total distances L plus L 2L. That means 4L square must be greater than 2 mg. So from here you got that q must be greater than 8 mg L square by small k into small k. K you can substitute here as 1 by 4 pi epsilon naught. I hope you have understood this. So minimum value you can consider this one. Thank you for your attention.